So the first problem that we had that question asked about was number 7. All right. And it said y is equal to x cubed minus 2x squared plus x plus 1. So the first thing it does is it asks us, it says, find the horizontal tangents of the curve. Alright? So in order to find the horizontal tangents of the curve, you need to find the derivative first. Because you need to figure out where is the slope of this function equal to 0, and then that would in turn mean where is the derivative equal to 0. Alright? So to find the first derivative, we have y prime is equal to 3x squared minus 4x plus 1. Alright? And what we need to do at that point is figure out where is this first derivative equal to 0. And we said not to use our calculator because on the AP test we need to be able to determine where the horizontal tangents are without using our calculators. Because there's this this degree of difficulty. So what we want to do is y is going to have horizontal tangents over y prime. Our first derivative is equal to 0. So we say set that equal to 0. In this case, it is a quadratic function. You probably factor it. So it's going to factor into 3x and then the x over here, and it's going to be a minus, it's going to be 3x minus 3x minus x plus 1. That's equal to 0. We're going to group these. So we're going to have, we're going to factor 3x out. That's what we do with x minus 1. And factor minus 1 out over here. And then use x minus 1. So you have 3x minus 1 equals, times x minus 1. So we know we're going to have 2 places where this is going to have a horizontal tangent because we have 2 factors. So 3x minus 1, we set that equal to 0. And we set x minus 1 equal to 0. And add 1 here. 3x equals 1. Divide by 3. X equals 1/3. Add 1 over here. And you get x equals 1 squared. X equals 1 and x equals 1/3 are where your horizontal tangents are. Alright. Again, the trick there is that you know how to factor.
Is that's our nervous. The new numbers that's in my spread.
What?
The minus 3x and minus
This minus 3x minus x we get by multiplying the leading coefficient and the constant, which gives us 3, and find the factor of 3 that can give us negative 4 when added together. So negative 3, negative 1, so you have negative 3x minus 1x. Alright. So now we're going to look at number 39. 9, 10, and 11 are going to be.
Wait, are there any one that has a numerator and denominator?
Not 9, 10, or 11.
I'm having this one. R equals x3 divided by 3.
Not x, not x3.
X cubed.
So all this is asking us to do is find the derivative. So y prime is equal to 3x cubed divided by 3 minus 1. Those 3 cancel out, so that is x cubed minus 1. X squared, yes. So, yeah, to answer your question, numbers 9, 10, 11 are going to be just like those, except 9 and 11, no, yeah, they're just like very similar to those.
Okay, well, let's see, starting on.
39?
Yeah.
39. Says, find the points on the curve, y equals 2x cubed minus 3x squared minus 12x plus 20. Where the tangent, where the tangent is parallel to the x-axis. The x-axis runs horizontal left to right. So it's just asking, find horizontal tangents.
That's how we know that one?
Yeah,
So
so,
like 7, and we're gonna do like 7.
just like 7, so you're gonna find the first derivative. That's gonna be 6x squared minus 3x, nope, minus 6x. So y prime is equal to 6x squared minus 6x minus 12. This is nice, the 6 is all factor, you factor 6 out and get x squared minus x minus 2. And that's going to be equal to 6 times x minus 2 times
So why did 12 not have?
factor the 6 out there. So essentially all we're really dividing each of these by 6. 6 divided by 6 is 1, right? 1 is squared, 6 negative 6 divided by 6 is negative 1x, negative 12 divided by 6 is negative 2. So I have each of my two factors. Okay, so I need to figure out where is my first derivative equal to 0. You have to find my horizontal. Huh? I'll be one that add up the negative 1. So, I have x minus 2, set that equal to 0, and x plus 1, set that equal to 0. That gives me x equals positive 2, x equals negative 1. So my horizontal tangent. With 6, you just factored it out, it doesn't matter. The 6 is never going to equal to 0, so I don't say 6 equals 0 because that's not true. Alright? And, I mean, you can think, if you wanted to, just, I know it said not to use your calculator on this problem, but, you can always check your work. So you can go y equals, 2x to the third minus 3x squared minus 12x plus 20. Right? Graph. So what you can do is, one way you can check this is you can say, okay, I'm going to find my horizontal tangents. My horizontal tangents mean my derivative is equal to 0. So if I know that x equals 2, we're saying that has a horizontal tangent, that means the first derivative at x equals p for this function would be equal to 0. So I can go second trace, derivative is 6, want to see what it is at x equals 2, and it says 2 times 10 to the negative, I don't know why it does that, 2 times 10 to the negative 6 is very equal to 0, right? It just is being stupid right now. So you have a second trace. The other one we said is negative 1, so we'll check negative 1. Says again 2 times 10 is negative 6. Okay, again, that is 0. I'm not 100% sure why it's saying that. Because if we do this, it makes no difference. There we go, 0. You guys got to be right there, 0, you can do that there is around the 3 days. Alright? So, questions about that? Okay, horizontal tangents is just a fancy way of saying where is the first derivative equal to 0?
Wait, go to 8 or 12, so go to 8.
8, 12?
So don't you have like 2 horizontal tangents?
8? Yeah.
Okay, I will have 1, that would be the second one.
Alright, so if we, okay, so first things first, it says you can use a calculator on this one?
Yeah.
Alright, so what we can do is this, what did you graph when you graphed this?
I don't remember.
Did you graph the actual function, or did you graph the derivative?
I don't know, look at.
8.
I don't remember.
Okay, so let's think about this. Where are the horizontal tangents located? Well, what do we have to find? We need to find what? First derivative, and then the horizontal tangents are located where the first derivative is equal to what?
Yeah.
Okay, so what I'm going to do, if I'm using my calculator to find out where my horizontal tangents are, I'm not going to graph my original function. I'm going to graph my first derivative. So, first derivative for number 8 would be 3x squared minus 8x and plus 1. And the reason that you're doing this here, and we said you can use your calculator here because this is not factorable. So I'm going to hit graph. Alright. So what I see here is this. I'm going to do the zoom system for a second. Okay. So this is the graph of my first derivative. Alright. I want to find out what my horizontal tangents are. So my horizontal tangents are going to occur where my first derivative is equal to 0. My first derivative is going to be equal to 0 wherever it crosses the x-axis. So it crosses the x-axis once here and once there. So I hit the second trace. I want to figure out my intersect or my zeros. So I go to 2. So my left bound, let's just say negative 2 for 1. Negative 2, that's to the left of this first 0. And then we'll say positive 1 is my right bound. Yes. And it tells me that my first 0 is 0.131. So that's that. That is the second 0 here. So this is the first place my horizontal tangent is equal to 0. My first derivative is equal to 0. So I figured out the second derivative over here, or the second x value over here to the right, so I'm going to hit the second trace. 2, because that's my zeros. Let's just say it's to the right of 2, so I'm going to say left is 2. Say right is going to be, let's say 4, just to be on the safe side. So 4, enter, guess it, and I get 2.535 is my second place where my horizontal tangent is. Another way you can do it, alright, is you could graph the original one, but actually you're going to stay away from that, because you don't know that stuff yet. So on those who are using the calculator, you would want to graph your derivative and find out where is the function crossing the x-axis. Alright? Cool. Alright. So, what I want to do right now is I want to have you guys try to calculate, all right, these first derivatives using your calculator. All right, so you're not doing this by hand. I want you to use your calculator to find what the first derivative value is for this function at pi over 4. I want you to find out what the first derivative value is for e to the sine x power of x at x equals -1. I want you to find the instantaneous rate of change of y equals that's a log of sine x with x equals 1.5. So again, that's just the first derivative at x equals 1.5. And I want you to find the equation of the tangent line to y equals 3 to the x squared power at x equals 0.725. Yes, you can put anything in the calculator. It looks like for the most part we did well on the first 3 1/4 problems. Well, you guys got the tangent, you guys found the derivative, decided the first derivative for them before. So, the easiest way, and the way I like to do it best most, is just use math 8. It's going to be in terms of x, cosine 2x, and then we're squaring that whole function, squared, and we're evaluating it at pi over 4. Enter. Okay, so you put 0. I'll get that. Alright. We go math 8. This one's nice. It's already like literally written for us, so we don't have to think too much. We have e to the sine x power, so sine x. We're evaluating that at -1. Enter. 1, 2, 3, 3. You all get that?
Yeah.
Math 8 is going to be as evaluating for x. There's a natural log of sine x. And now the important thing here is notice you have 1, 2, 3 parentheses facing that way. So you have 3 over here, so 1, 2, and 3. We're evaluating it at x equals what? What? 1.5. Enter. 0.071. Okay. And finally, yeah. Be on the safe side. To be on the safe side, and then you have math 8 evaluated x. So you have 3 to the x squared power. We're evaluating this at 0.725. Enter. We get 2.38 or 2.838. All right. So what we know is that for this one, we need to know our slope, which we said was what, 2.3 or 838. Okay. We also need to have a point. So a point P is equal to the x value of 0.725, comma, we have to figure out the y value. So we go back here, we have 3 to the 0.725 squared power. So it's going to be 1.782. Alright. And at that point, we have we use the formula y minus y1 equals n times x minus x1. So that's going to be y minus 1.782 equals 0.7. Oh, that's an extra. 2.838. 0.38 times x minus 0.725, and that is the equation for our tangent line at the x value 0.725. All right. All right. So, So, moving on from there. Differentiability. Okay? We've been talking about differentiability, we've been differentiating. Alright? So, not yesterday, but for you guys on Wednesday, we talked about derivatives of functions, how to find the slope of a function at a given point. Right? And the question we need to ask ourselves, is it possible to always find the slope at a point? Are there points where we may not be able to find the slope? Are there points that, in that case, these points would be called non-differentiable? Alright, so are there any points that are non-differentiable? So, what do you guys think the answer is? Is it always possible? Is it possible to always find the slope at a point?
No.
Good guess. Alright, the answer is no. Alright, and when we cannot find the slope at a point, that means that the function is non-differentiable. Okay, so there are two conditions. You don't want to write this down. There are two conditions that must be true for the function to be considered differentiable at a point x equals a. Okay. So the first condition is that the function must be continuous. Right? So the function must be continuous. Didn't want that down. Right? So the function must be continuous. Right? Second one, alright, is I'm going to write the second one, not really like mathematical. I'm not going to use a bunch of math words, I'm going to use a bunch of easy words that you guys understand. Alright? So, the second thing that must be true is the slope. Nope. On the right. Alright? At x equals a equals the slope on the left at x equals a. Right? And, whoa, actually that worked pretty well. Just, yeah. So, slope on the right at x equals a equals the slope on the left at x equals a. And that's going to be, that might not make much sense, but once you see some examples, once you see some, like where the graph is not differentiable examples, that will make sense. All right. So let me just ask you this question: if the slope on the right and the slope on the left at x equals a must be equal, what are we going to be looking at? What do you think that find right away? Slope, and how do we find the slope at x equals a? The derivative. So we're going to be comparing the values of the derivatives on the right hand side and the left hand side. Alright, so everyone have that? Here, you good? Alright, so there's 6 examples of places where a function could be non-differentiable, and I want you to write these down. Alright, so the first example would be something that looks like this. Right? Here's A, and so it's right here, not differentiable. Okay, the reason it's not differentiable here, x equals A, is because of what we call this is a corner. So if a graph makes something that looks like a corner, all right, it would not be differentiable. This right here, I mean, if you recognize it, this is probably some form of an absolute value function, all right? So what we would then see is that if you look at the slope of the left-hand side, now we said the slope on the left and the slope on the right, in order for this to be differentiable, they must be equal, all right? Well, the slope here is negative. The slope on the right is positive. Well, a negative number does not equal a positive number. Therefore, right here, x equals A, this function is not differentiable because the slope on the left and the slope on the right is not equal. If you get a negative slope, you have a positive slope. All right. Now, it's not always going to be a corner where it's just cut and dry, looks like an absolute value. All right. Now, another one that you can have is what we call a cusp. All right. What that's going to look like is something like that. We call this a cusp. Okay. Again, you can definitely see that the slope on the left is not going to be equal to the slope on the right. All right. You have one where it's positive and one where it's negative. All right. Now, another way is where you have, and I'm going to exaggerate this a little bit, is where you have what we call a vertical tangent, or looks like this. Okay. Now, real quickly, does anyone know? So what this is saying is, so they're not going to put that x into this. This is A, and then this here. So what this is saying is, at x equals A, my tangent would be, and this again, this is what extremely exaggerated. My tangent line would be a vertical line. All right. What do we know about the slope of vertical lines? Sean, do you know anything about the slopes of vertical lines?
I don't know, usually, horizontal.
You usually do it horizontal. Vertical lines, the slope is undefined. All right. So if the slope is undefined, I mean that kind of makes sense that it's not differentiable. I mean it's undefined at that point. That derivative would be undefined at that point. So it's not differentiable. Typically, what you'll see is if you so one function that you'll see a lot that has a vertical tangent would be the cube root of x at x equals 0. All right. So that function in particular has a vertical tangent. Alright, now, the other ones, so those are, that's where, no, those are the three instances where the slopes on the left and the right are not equal. Alright? The other ones, alright, are discontinuous because, are not differentiable just because they are not continuous. So you can have a whole. Okay? This function is not continuous. Therefore, it's not differentiable at x equals a. Okay? Other things that we have, jump discontinuities. Okay? That's at x equals a. This is a jump discontinuity. Again, this is not differentiable at x equals a because it's discontinuous at x equals a. Finally, you have vertical asymptotes. All right, vertical asymptotes. All right, so again, that's discontinuous at x equals a. So what you notice is that the first two I showed you, they are not differentiable. So they're continuous but not differentiable. All right, and the last two I showed you, they aren't continuous, therefore they're not differentiable. All right, so you can have continuous functions that aren't differentiable. You can, if a function is not continuous, it's definitely not differentiable. Okay? So, questions about that? We're going to get a few examples here. All right. So this problem says, show the function is non-differentiable at point P by comparing left and right derivative values. Okay, so what it's asking us to do here is telling us it's non-differentiable. It wants us to show that it is non-differentiable. So just by looking at that, could we give a reason why it's not differentiable? It is a cusp. All right. So what we're going to do, we need to, so we want to prove, we want to show this is not differentiable. To show it's not differentiable, first of all, is this continuous? So what are the two things that must be true in order for it to be differentiable? All right, so it must be continuous.
The slope on the right at x equals a, with the slope on the left at x equals a.
And slope on right at x equals a must equal slope on left at x equals a. Alright, so is this continuous? Is this continuous? This function is not continuous? Yes, it is. So it is continuous. So now we need to check to see if the slope on the right is equal to the slope on the left. Well, so we can tell they don't look the same, but we don't want to do that. We want to prove. Alright? So we have the line y equals x on the left and the function y equals 1 over x on the right. So, do we know what the slope of y equals x is? Just without you having to do any calculus? What is it? Okay, well, we can find the derivative of it. So, it's just 1. So the derivative is, so dy dx, and we'll say this is the right, it is going to be equal to 1. So what is the slope on the left-hand side? So, slope on the left is equal to 1. Huh? Not what?
So on the right is 1, on the left is 1. So
No, on the left is 1. Alright? Now, on the right, y equals 1 over x. We have to find the derivative of that. and then plug in 1. So it's going to be, so we can rewrite this as y equals x to the negative 1 power. So dy dx is going to be on the right, going to be equal to negative 1 x to the negative second power, or negative 1 over x squared. So if we evaluate this at x equals 1, you have negative 1 divided by 1, which is equal to what? Negative 1. So, negative 1. Is negative 1 equal to 1?
No.
Therefore, the slope on the right side of the function, the slope on the left side of the function at x equals 8 are not equal. Therefore, it's not differentiable at x equals 8. Make sense? So all you got to do is find the derivative on the left side, plug in the value of a that you're trying to find, or determine if it's differentiable at, and the derivative for x. Okay, so this one says, where is the function f of x non-differentiable? Okay, again, Shamar, what are the two things that must be true in order for a function to be differentiable? Alright, so it has to be continuous, and the slope on the left and right need to be equal. So, first thing we need to do is figure out this function is continuous, right? So, how do we figure out if it's continuous? We're just going to plug in x equals 0 into each of these functions. Now notice, this is a piecewise function. So you have the left side and the right side. So if I plug in 0 for x up here, I'm going to get f of x equals, well, I'm going to get f of 0 is equal to 2. If I plug 0 down here, I'm going to get f of 0 is equal to 2. So since f of 0 at both of those is equal to 2, this function is continuous. Alright? So it is continuous. Okay? Now, what we need to do now is we need to show that dy dx, this is my own notation, and the left is equal to d, not d, dy dx to the right. Okay? So, again, here's what we do. We need to find the first derivative of the left, first derivative of the right, and plug in 0. So, the first derivative, so dy dx on the left is equal to 2 cancels out, so I have minus 2 and then minus 2x. Alright, I plug 0 in there, we get negative 2. This 2 goes away because it's constant. So that's the derivative of 2 is 0. This is the derivative of negative 2 times 1 is negative 2. X goes away and 2 comes out of point, so minus 2x. So then we have dy dx on the right is equal to, that cancels out because that's the derivative of 0, plus 2, so 2 plus 2x. Plug in 0, I get positive 2. Are the slopes equal? No. So what we can say is that this function is non-differentiable. So where is the function non-differentiable? It is non-differentiable at x equals 0. Why is this function not differentiable? Is it because it's not continuous?
No, so they're equal.
What's not equal?
The
The slopes on the left and right hand side. So yes, it's because the left hand derivative and the right hand derivative are not the same. Okay? So, I think one more example. Alright. this we actually want to find A and B so that this function is differentiable everywhere. Alright, so here, we've done problems similar to this on our homework. Alright, but we need to figure out two things. So we need to, first of all, we need to figure out, what is this function. So we need to figure out how to make this function continuous. So this function needs to be continuous. And we also need this function to be true so that the derivative on the right is equal to the derivative on the left. Alright? So we need those two things to be true. Alright? So the first thing that we want to do is we are going to let's start by figuring out this part about the derivatives. Okay? So we know that in order for the slopes to be the same, we need to be dealing with this derivatives. Alright, so what we have here is we're going to take the derivative of this. So the derivative of a x to the third, and this is the left-hand side, is going to be 3a x squared. Alright, again, the a is just going to be a number. So for now, I'm just leaving that there. Okay. We also know that the derivative on the right is going to be 2x. The b goes away because the b is a constant. Alright? So since the b is a constant, we know that the derivative of b is 0. Now, we want this to be equal to this. We want the left slope to be equal to the right slope. Alright? Now, what we also know is that our x value is what? 2. So we can get rid of the x by plugging in 2. So we're going to have 3a times 2 squared equals 2 times 2. 4. Okay? 2 squared is 4. Times 3 is 12. So we're going to have 12a is equal to 4 divided by 12 divided by 12. You get a is equal to 1/3. Okay, so you found A. How many people get 2 squared is 4. 4 times 2 is 12. So that's okay. So A is 1/3. Now I need to figure out what B is. Now this is going to be where the whole thing about it being continuous comes into play. Okay? So in order for this to be continuous, we know that the left side of this equation must approach the same thing as the right side. Alright? So what we know is that when I plug in 2, this should be equal to this. Alright? Now I know what x is. X is what? X is 2. I know what A is, 1/3. So what I know here is that 1/3 times 2 cubed is equal to x squared, which is just 2 squared, plus b. 2 cubed times 1/3 is going to be 8/3. And that's equal to 4 plus b. Subtract 4 from both sides, and you get b is equal to -4/3. Okay? So, those are my values, A and B, that make this function differentiable everywhere.
Wait, what did you say about first? after you say -4, so B is that?
So B is -4/3. So if A is 1, so what this would really be is, so this would be 1/3 x cubed and x squared minus 4/3.
Okay, why is it negative?
That is not, well, why is this negative?
So why is that?
Why is this negative? 8/3 minus 4 is a -4/3. That's what you're calculating. Because if you have 8/3, that's only 2.33333. I subtract 4 from 2.3, that's going to be negative number. Math. Fraction. Questions about that? The first thing you want to do, take the derivatives of both, solve for one of the variables. Once you know what that is, you go ahead and try to figure out when it's going to be, or what you need. The second letter to be in order for it to be.
So find B, just plug in.
I just plug in my x value and the a value I found
For the first one.
into this function and this function,
Yeah.
set them equal to